Hi, my name is Wan Arika Ashraf binti Wan Ali. My matrix number is B0822102228. So today we would like to present about our mini project for control principle BEEE2364, which is we're doing door lock system simulation and control using PID controller. So for abstract, to develop an RFID-based alternative to the traditional key method for locking and unlocking doors that is more effective, the PID controller system will then be mathematically modeled and the data will be validated using MATLAB software. Lastly, to introduce PID into the system and operate in the best way possible to create a stable control system. The analysis of system stabilization using MATLAB software include time response analysis, root locus, boot plot, and Nyquist plot. To sum up, adding a PID controller to the system has significantly improved efficiency and keep the actual output of the door locking process as close as possible to the desired or set output. The door was locked and unlocked using an Arduino-based project that used a proportional integral derivative PID controller and RFID technology, based on results from prior research and application, as well as comparison with the result we obtained for this research. Technology using PID controller can be considered more efficient and stable than other types of controller available in the market. Radio frequency, text or transponder, and reader are the two main components of RFID systems. The open standard-based PID system can offer an application process that is well known and simple to comprehend from a variety of fundamental components. The RFID tag, transponder, and the reader, transceiver, and the back-end application system or database, all of which depend on a computer network.
Hi, my name is Muhammad Amir Rafiq bin Muhammad Yusof. My matrix number is B0822102249. Today, I want to present about block diagram of the system. The system was made up of a number of parts, including an Arduino Uno controller, an RFID reader, a stepper motor driver, and a DC power supply to keep the system running while the door was being locked and unlocked. The block diagram for the entire system must be ascertained from the schematic diagram. Making a block diagram serves as a tool for identifying which component belongs to which area of the controller system. The Arduino Uno controller, for instance, will serve as the control device, and the stepper motor will belong to the group 2 actuators. Every component in this figure is categorized using a block diagram model according to its function. Okay, next I will go to the mathematical model. Our system can be broken down into two electrical subsystems and mechanical subsystems. The resistor, inductor, power supply, and controller device will all serve as symbol for this subsystem in the electrical subsystem, while the mathematical subsystem will house the stepper motor, gear, and push button. By using our schematic diagram as guide in figure 6, illustrate how the subsystem is divided. So the transfer function of the system written as below. So next I will go to the first mathematical model, which is electrical subsystem. The electromagnetic field, EMF, voltage, resistor, inductor, and power supply are all components of an electrical system. The following is the equation for the electrical subsystem. Thank you. Next, I will pass to Dashwin for the second mathematical model.
Hello, my name is Dashwin. My matrix number is B0822102207. So today we're going to talk about mathematical model for the second one. So the second one is mechanical subsystem. For the mechanical subsystem, we will begin with the stepper motor, transfer the motor torque to the drag and pinion system, and finish the micro push button, whose operation mechanism we will assume has the same workings as a spring. We simply take the mathematical model that already exists for the stepper motor and substitute the electrical subsystem EMF constant for it. The rack and pinion equation is as follows. So as from the rack, T equal to motor torque and F of T is equal to tangential force and R equal to radius of pinion gear. So note, next we combine both equations by the relationship of tangential force exists in both equations of the result in as below. So combine pinion and rack equation. After that, convert the equation into power transformation and replace into electrical subsystem and replace into mechanical subsystem. So prior to obtaining the transfer function, the previously obtained mathematical equation is transformed into Laplace transform. So the equation is below. The equation is finally rearranged according to the relationship between output and input with the displacement of micro push button as the output for our system and the voltage from the power supply serving as the input and X when the lock and unlock are activated, displacement and voltage interaction output over input. So below is the completed RFID door lock transfer function. Thank you.
Hi, my name is Muhammad Syahmi bin Muhammad Zaidi. My matrix number is 0151. Today I would like to present about Simulink model. The block diagram of an open and closed loop created with Simulink software is shown in this figure. And step input is serve as the system's input. Figure 7a shows the block diagram for an open loop system which has no feedback, while figure 7b shows the block diagram for a closed loop system which has unity feedback. Next, steady state graph, a comparison of the response for the steady state graph of the open loop and the closed loop system for the PID door lock system. The graph for open loop response with the step input will be like this, and closed loop response with step input will shows like this. Next, parameters. The parameter of the proportional controller P is initially set to the value of 1 before tuning into any value. It is best to start with a small value of P and gradually increase it. When we select the controller to P, the only parameter that we can change is the proportional P value. We can also tune proportional controller by using PID parameter by selecting the controller type to PID and next set the parameter of integral I and derivative to 0.
Hi, good evening. My name is Nur Suhaila binti Muhammad Sulaiman. I'm from BEET. My metric number is B082210-180. So now I'm going to talk about result. So we have two results here for figure A and figure B, which is figure A and figure B is depict the step response graph prior to the PID controller being inserted into the block diagram. So for the graph A, figure 1, is step response graph without PID. And for the figure B is final step response result after the controller turning. Okay, so now we will start to tune the PID controller to a specific parameter to reduce the amount of overshoot and reduce the amount of time to achieve steady state condition. Next, we obtain the PID parameter that can be used to modify the step response graph after the tuning process is complete. In order to achieve the best result, the proportional parameter should be at least set around 9.6488838. The integral parameter to 78.2859329. And the derivative parameter to 0.045137596. In table 2, a comparison of step response graph with and without any controller, with a PD controller, and finally with the PID controller is presented. When compared to another controller variable, the application of a PID controller produces the most efficient result with the lowest overshoot percentage. As we can see in this table, we have our no controller, PID controller, and PD controller. Alright, so the conclusion of our mini project, the fundamental law governing mechanical system is Newton's second law, which has been derived from mathematical modeling of each subsystem in the door lock system. The use of this law to create transfer function models for various mechanical systems. Next, it is known that Kirchhoff law are the fundamental law governing electrical circuit as a result of deriving the electrical subsystem. Our system uses PID controller to speed up the process of reaching steady state condition while reducing overshoot values. The practicality and simplicity of the PID controller's implementation are its benefits. If the system parameter can be achieved precisely estimated, the PID gains can be designed based on those parameters. Additionally, if the system parameters are unknown, the PID gain can be designed solely based on the system tracking error and treats the system as a black box. However, PID controller frequently have to balance the effect of all three gains on the overall system, which can compromise the transient response and cause oscillation, overshoot, and setting times. So that's all for our presentation of mini project. Thank you.